these generators are like forever.
I started the recording.
Okay, good.
They're just talking about a generic gRPC service, right?
Yeah.
Where
you can
and maybe
so I was thinking, yeah.
One thing, just for the benefit, for my benefit at least, and maybe for the others listening to this later, maybe explain what as far as GPRC is and what a basic GPRC. I understand it's in regards to communication, but maybe just kind of start off with that basic framework.
So I cannot say very deeply how gRPC works. For me, this is just another protocol that you can talk to, between two programs.
Okay, so it's the protocol to talk between two applications. That's okay. Yeah. That's what I needed to get a handle on.
Right.
In a sense, it's
it's has strongly typed data in a very compact form, efficient for communicating.
Okay.
But you have to know what the data structure is, the data type.
You have to know what the data.
Decode it.
Okay, so you got.
And what we would really like is we would like to just get JSON data.
Okay.
No matter what the data type was, we just want to be able to deal with all of them in JSON.
Okay,
so what I think Thomas was suggesting, and this is a little off topic for the Consensus Colab, I'm trying to understand what he was proposing yesterday, and I think I understand it now, is talking about having a generic gRPC to JSON gateway.
Yeah.
Okay. What was that last word? Data what?
Gateway.
Gateway. Okay.
Okay, where we could say, take this data, which is JSON, and send it in gRPC to
something else that's to JSON.
To some R node or something that talks gRPC.
Okay.
And then get back a result and convert that to JSON and give it to me.
Okay.
That's what you were talking about, right, Thomas?
Yeah. And I have two things to maybe clarify. One thing is gRPC is the protocol that is not supported by browsers, right? So and this is the part of the communication, right? So another thing is the protobuf. So they are like mixed together, but they are two separate things. Protobuf is the type definition, like in similar to GraphQL schema, right? You just say, okay, I have these types, and my service, my application will respect these types, and accept these requests and response with this type.
Tomislav, did I hear you correctly say that gRPC was not supported by the browsers?
Yeah, and that's the problem. So Ed, in his implementation of OLED, he's using Envoy like a gateway service.
I'm sorry, he's using what?
Envoy.
Envoy.
Envoy. So,
Envoy. Oh, okay. Envoy. Yeah, I think I've heard.
Maybe I not spelled this correctly.
Envoy.
Okay, so the gRPC doesn't have to do with the types. The protobuf has to do with the types.
So yeah, the protobuf is a type definition. Where should I post this? The definition of this service is defined with protobuf types, right? So now we need two things. We need communication with gRPC protocol, and we need somehow understand what we exactly getting from the server. And this is written in the types. So for that purpose, there is libraries to generate this kind of conversion, JSON, for example. But when you make this conversion, you usually get this all this nesting in your types. Like you don't just get the string, you get some object which has some another property inside, and then you get the string. So it's not very useful for working in the something like a JavaScript.
Okay.
So we have all of this like a separated tools that we can combine, right? So my suggestion was that although this can make it work, right? But it's very difficult to keep it in sync.
Okay.
So my suggestion is for now, just for the purpose of testing, that we expose some service, some HTTP service or GraphQL service that is very easy to use inside the browser.
Okay.
But what is the problem with this? We put all the trust in this service. Okay. So this is not very good. So it would be nice that we can somehow protect. The question is how to manage this service, right? Who will have access and.
Ideally, each person would run their own service, and it would be could be part of their personal proxy, right? That they
I was thinking just like that. But when you say to someone, if you want to have a wallet, you need to spin up one VPS instance. This is not very friendly. But yeah, we can definitely say you can do this, or you can use some shared service. Maybe.
I think that if you put together all the different reasons, good reasons for having a personal proxy, that people will find that it's worthwhile. Okay, for one thing, the proxy can obscure their location on the net, and they're harder to track. For another thing, it can hold their credentials for them and act on their behalf, even when they're not online. Even when they're not connected, it can act in their behalf. So if you combine these services, of the personal proxy to handle this gRPC protobuf interface, then it becomes worthwhile to run it rather than running a separate envoy and a separate, server to do your gRPC, whatever, your protobuf.
So it is very similar thing to pushing messages from to your phone, right? I'm not sure how you're familiar with web push notifications. So you want to receive notifications from the server. So this is like a push communication, and if every application in your phone is connected all the time to its own server, this is very problematic for the battery. So there is like a service offered by Google, but I think there is also other services. But I'm not sure how this is connected because you have only one connection. So and how this is done? It's you're using the certificates for both sides, right? You must have you register with your public key, and then you send the message.
This is what WebSocket can be used for, right? You can set up a WebSocket to your proxy which has listening, which your browser is listening to or whatever.
And this is very this WebSockets can be used directly if your page is like running, right? But you need to use different strategies if your page is like closed or right. So in that purpose, you have a service worker connected to this web push notifications. So in that case, you can have application which is really only a web page, this PWA application, which is not running really. You only have installed your service worker. And when service worker receives a push notification, which is not directly connected to your web application, you can bring up application window from your application. So I was thinking that we can do exactly that. We can build this kind of wallet without creating like a real desktop application. So we will have this PWA application that is installable on every phone, and we have a desktop application.
Yeah, I think that, I mean, that architecture is I think, correct. And, I'm thinking, we can, even for things like the events that they have on Ethereum, if we had events in our logs or whatever, in our chain or whatever, we could trigger these notifications, which could be native notifications, could be just something listening on the WebSocket, whatever.
Definitely. WebSocket is when you are online and push these offline notifications, you can use it in the background. So I will try to make this kind of like a template for the next week. So,
oh, wow. Okay. Thanks, Tomislav.
Because I'm thinking that maybe we can have some kind of tutorial videos to how to build your own wallet, right? When we build this part of the on the website, right, on the server side, we can easily say, why don't you build your own application on the client side? You just connect to these services via GraphQL or HTTP. You don't even have to use gRPC, and you can build your own wallet.
Oh, okay.
Very, very easy. So,
neat. Very good.
Yeah, I would really would like to do that. I guess Jay was suggesting also doing a row bash wallet, basically the command line wallet. Should be pretty straightforward, following documentation. I would like to do that, and then we can hook it to Robot. We could even have your proxy.
with the notifications.
You could have your proxy used with the notifications.
There we go.
And it will be great that later we can build this whole web push notification server in Robot, right? Because this is now implemented. Google made some one implementation, but there is another implementation which depends somehow on the Google, but it's like I think just open source is the code. So, but the same system, it's very closely related how you're sending exchanging messages on the blockchain with Archie. You are protected with a private public key, and you are pushing this to Google servers. You don't want to Google is able to read your messages. Right?
Oh, okay. Very good.
So, but when you try to understand the whole system, it's so complicated.
Yeah.
I mean, you have helper libraries to do all of this heavy lifting, but when you read all of these things, what is going on in the background is super complicated.
Yeah. Trying to make sense of it all is a
Yeah.
challenge. Yeah.
Yeah. Well, if your proxy is, registering all your events, then how it notifies you is variable. The proxy can notify you any way that you, by whatever rule you have in your proxy, right?
Yeah. And
okay, it doesn't have to be one standard way of doing the notifications.
It's a question of how many connections do you have from each device. I see this as per device. Right? You don't want to have more than one connection to receive notifications. Maybe if you want to have like a backup link or something, but you want to save the battery, right? But if you install, so if each application has its own way to deliver notification, it's not like a,
no, it's not each application. I think that you have a service running, a proxy service that where you have events triggered. Then you have rules as to where you want that to go. Now, yeah, if it's to a device, a particular device is where you want that notification to go, then you might uses that notification service. I mean, it may be that the notification that you want to get is a text message. Okay, it should be different from on your phone. I mean, there might be, I guess you can, having a standard is good, but
you mean you can have some kind of collector all of this notification, and you can decide what you really want.
Right. Well, you want to have a user agent. You want to have a user agent on the net that that collects your notifications and distributes them along with other things. The user agent is what acts on your behalf on the net, and that's where you need that's what we need as part of our self-sovereign architecture. We want our user agent to run in the browser, but we also want it to run online all the time, even when we're not there, to handle things like notifications.
Oh yeah, definitely.
And to obey our rules. Okay, to basically run our robots. Okay, so we have our contracts of how
I think we need like a better control or notion. What is the device, right? Now you cannot easily run your web server on your phone, right? You cannot easily say I will keep my phone like on for hours, and I will use it as a web server. It's very difficult to do something like that. But why not, right? I mean, it's processor, memory, it's everything there. So, or keeping files and.
Okay, so do we have something for Consensus Colab today? Did somebody want to?
I was looking at ArchChain's consensus this week with Casper, and it's something I hadn't really looked into that much before. So, like seeing how it really works and seeing how they're able to make a block DAG out of Casper consensus, which I've always thought of as being more of a blockchain. I thought that was really cool. I don't know how well you guys know how that works. Isaac, you probably know pretty well.
Yeah, you're talking about with the justifications and whatnot.
Yeah, with the justifications in there, but I mean that's also just part of Casper. But
Yeah.
mainly they just take the idea of like the ghost rule, and they say instead of having just a tip, you have an ordered list of a whole bunch of tips, and each one is like a fork, like a separate spawned process, which would be like a parallel process.
Interesting. So we've talked a lot about kind of like CBP Casper and like the general framework, but not the specific implementation that Earthchain has. And I haven't done a lot of personal research into that either. So I would love to hear a little more about it, honestly.
Yeah, it's pretty cool. I mean, yeah, it definitely raises questions for me too. I have some things I'm wondering about, but I don't have a way to like draw things, which is always super useful.
Yeah.
There's a video that I watched that really showed it well, but I don't know. I can just try to explain it. So I mean, yeah, the idea of parallelism in the row VM and how it matches with spawn processes matches really well with the block DAG structure. So when you have two parallel processes that don't need to be ordered in rowing, then those can become a fork in the blockchain or the block DAG, and both paths can be valid. And under the ghost rule, you would always choose the heaviest observed path. But in this ghost rule, instead of just choosing the heaviest observed path, you just create a list of all the heaviest observed paths as an ordered list. So there's always going to be the main process in a program, and we can kind of consider our chain as like the blockchain. The main blockchain is the main thread, and then it spawns just kind of like the fork rule of like any operating system, like a POSIX operating system. That would be spawning a thread, and those parallel threads can match up with the main thread later by having some kind of ordered dependency, by sending back to the main thread or receiving something from the main thread. These other threads can join back up. So it's therefore like important to have this ordered list and not just the main tip, so that we can consider other threads as like valid paths in the DAG. And it's really just that simple transition from the tip to an ordered list that allows us to use Casper not as a blockchain fork choice rule, but as a block DAG fork choice rule, which kind of blew my mind because other than Hashgraph, I haven't really seen how anybody else does that. And I'm wondering like what the parallels are there. So like one of the interesting things about Hashgraph is in order to decide that an event has finality, it needs to be strongly seen by 2/3 of all the validators in the network. So I think from what I saw with our chain, they have a slightly different concept, and this might have to do somewhat with their hierarchical namespace sharding, which I don't really understand. But I think they have some kind of threshold finality. So they don't just have a 2/3 finality of the whole network. And this allows a specific process that maybe only a few people care about to have some concept of finality without having to have 2/3 of the entire R-chain network agree to that one spawn process.
Oh, interesting. So you're saying like 2/3 of the validators in that particular namespace would have to like come to consensus on that particular process or whatever, and then that would basically be the finality.
Yeah. So I mean, yeah, in namespaces, it's pretty easy to partition, like that. But I'm wondering, and this is kind of the edge of my knowledge, what happens when you just spawn a simple thread that you start it's doing continuations on and it hasn't matched up with the main thread, it's not really, you don't want to like spawn a whole namespace for this new thread, but you want to have some concept of finality maybe for the people who care about it. So yeah, it's not something I've looked into much, but I think it's like an interesting idea of like this threshold finality. So
yeah, so I remember this concept that they were talking about in the paper called cliques, and I didn't know if that came up in like some of the code that you were looking at. I think that's the finality that they were talking about in like the CVC Casper paper.
What'd you call it?
They called it cliques, and at this point, I don't really remember what a clique is. I think it's like a graph theoretical notion. Some kind of like highly connected subgraph, but I don't remember like the specific definition or anything.
Like CLIQUE?
Yeah, exactly. Yep.
Gotcha. Yeah, that sounds like it would be it.
And how these threads are related to continuations in rolling, right?
Yeah, I was gonna say, do these different threads have something to do with like different reduction paths for like COM events or something?
Yeah. So,
Are they represent exactly this DAG, right? you're like unfolding continuations or like a par. A par is like a branch, right? When you have this branching in the deck.
Yeah, exactly. And a continuation would be like any kind of dependency on a previous event. I mean, a send or a receive, and the continuation from that would be the line down, and then the par would be the branch. Yeah. And then the join itself from like the main thread and with some continuation from a par, would be like sending back to the main thread, some dependency there, if that makes sense. So like you have a par and it forks, and then you have a continuation on the left side, and that continuation then sends back to the other process that was spawned by the par, and then you have a join. So the edges are just the dependencies between the processes, just in ordering.
Yeah, and when you save the continuation, you really just release the thread, because in that case you cannot do any more reductions. So.
Say that again.
So when you do reductions, right? You can. So when you don't have any other reduction, you spawn a thread for a par, and you don't have any other reductions. You just release the thread, right? You save the continuation. You just release the thread.
Yeah. So I mean, it's kind of different when you're having like external input, though, right? So like you could imagine a par with like a user interacting with a thread or something like that, a process. And that could be the reduction that allows for the continuation to happen. That's kind of what I'm imagining. That's the only way that you could reach a chain without branching every time, right? Is if you par with like a user's input.
Yeah.
Yeah.
And what Greg was on the last session, Greg was explaining something about buffering this parallelism, right?
Buffering what?
This parallel computation that they are doing. So I'm not sure if this is related to Casper or not. So this is what I'm not sure. He was explaining that they can do it in sequence and everything will be great, but it will last too long. But you can also do all of this thing in parallel, but you suck all the memory. So you need to have something in between.
Oh, to like batch them together?
Yeah, one batch. Yeah.
Oh, gotcha. Yeah. Yeah, that would make sense. Yeah, I think that's really interesting.
I'm not sure what. Is this something for Casper?
Yeah. Here's the video that I had watched. Somewhere in this video, he has a good visualization of the graph. Yeah, around 30 minutes.
Oh, is this Ken presenting?
I can't remember his name.
Oh, okay.
Do you know him?
I mean, I've seen a few. Hold on a second. This might be a totally different video than what I was thinking of.
Michael Birch.
This is Michael.
Oh, this is Michael Birch. Okay, I don't think I saw this video. Oh, this is from Mark on 3. Cool.
Yeah.
Not sure.
Yeah,
I
they call it inclusive ghost. That's the ordered list version of CBC Casper, the ghost rule.
Yeah.
So you have your own blockchain, right? You do all these reductions on your chain, right? And when you want to do consensus, what are you doing? You are comparing this with some other version of reductions, right? So you have a different point in this deck, right? That you want to like order, right?
What do you mean by a different point?
I mean, if we synchronize our blockchains, right, in one moment, and then you do reductions on your machine, I do reductions on my machine, and both of these reductions are okay by the semantics of the language.
Yeah.
But we don't have the same deck, so I'm sending you my deck, you sending your I'm sending to all the other validators, and my deck, and you are sending your deck.
Mm-hmm.
This is the part where the consensus is, right?
Yeah, exactly.
We're trying to merge two branches, right?
Yeah.
Yeah, you're trying to decide like which reduction, you know, is the one that is the true reduction or whatever.
Yeah.
Hmm.
So what does it mean to send this multiple times, like in error correcting codes? You want to convince someone, you know, this is the real reduction.
You just spam them with that.
Yeah.
You have more money staked.
Yeah.
Yeah.
Well, yeah. Because does it cost the validators to send those messages around, or is it just when you want to like add information or, you know, deploy some code to the actual R chain?
I mean, how this is solved in Hashgraph?
Yeah,
you're just sending messages like crazy, right? And just
yeah. I think the idea is that each event you would tack on a little bit of stake.
Yeah.
And if that gets accepted as final, then, you know, you've ended up spending it. And if not, then you wouldn't have to spend it. So if, like in our chain, if two competing people both stake on valid blocks and only one can get accepted, then that means the other person doesn't have to risk losing their money.
And Greg was saying that in this error correcting codes protocol, you have like a final number of messages that you can send. Like this is the source of this synchrony constraint. So I'm not sure what this means, that you can send only this number of messages and, you know.
I hadn't heard of that. I haven't seen much about his error correcting theories.
I mean, in that case, this is different from for example, from Casanova, where you have a limit on time, and this will be the limit on what space. if you limit the, I don't know, structure of these messages that you are sending. So
That's basically what he did, was he used it to define the location, or the anti-de Sitter space definition of when you've looked far enough, and you can, without having clock time, you can come to finality by saying that you've looked as far as you need to look for the best error, the best error correction or whatever.
Wait, so by looked as far as you need to look, you mean you've seen like this certain number of messages or something, and that's like, that you've seen enough? Or there's some small disconnect that I still have with this error correcting code business.
Yeah, it has to do with, I guess, putting all the messages into a space.
Yeah.
Okay, so that you have a locality.
Yeah.
Okay, and if you make that locality big enough to be an environment, okay, then you can get sufficient evidence of something being true in that environment.
Okay.
It's the way I understand it.
Let me take a stab at it. So with the error correcting code, it's space and time. So you can have a limit on one or the other. So if you have a limit on space, a certain number of validators, then you can have unlimited time, or a great amount of time. Or conversely, if you have unlimited space, then you have to restrict time. So it's either one or the other. There has to be a limitation, and this is where this constraints come in for the error correcting code. It's the goal is to get to an agreement, a finality, and you have to restrict either space or time to get there.
Yeah, interesting.
Cool.
Here you go.
So if you have messages, so can Jim, can this be this space can be extended if you know who sees, who sees who messages, who sending to messages to whom? Because this is how they're very similar to hash graph, right? You know what things happen before, and
yeah, I have to look back at how that's constructed. I can't think of it offhand. But I did want to try to understand how we do sequential processing, and I guess handling of equivocations. Okay. And do they really imply the offender is not following the protocol?
Yeah, the way that they're able to do that with Casper is through attestations. So when you propose a block or a transaction or whatever, you have to give a list of a proof for why you believe this block to be valid.
Yeah, I'm much more basic than that. I'm going back to this simple sequential process. Okay, this get ticket contract, which we looked at once before, which just assigns a sequential number to the ticket. Okay, so
so you mean on each machine you will get the different number?
So this is, username, got ticket number, or whatever. It doesn't even return anything; it just logs it. But we we all, okay, in the sandbox, okay, we all connected to a different host in the sandbox, and we do a, where are we? I get jump there. Okay, so, and if we do it all at the same time, we'll all get the next ticket number.
Yeah.
Okay, well, on each of our nodes, the current ticket number would have been 4, and we would have all gotten ticket number 5. Okay, but obviously, that's not.
So only one will succeed, right? All the others will would need to replay the deployment, right?
Yeah.
So
So for this, it wouldn't be an equivocation, and that goes back to the attestations. When everybody submits that ticket request, they don't in the proposal mention that they've saw the other ticket requests that happen simultaneously. So it's not an equivocation. It's more just a mistake or like unknowingly submitting it. So when I receive, like Tomislav's request for ticket number 4, and then later I receive Isaac's, I say that Tomislav's already exists and Isaac's therefore can't work. And eventually he'll see that Tomislav's exists on chain and we've reached consensus, and so he'll resubmit it for ticket number 5.
Yeah, I guess that was my question. I mean,
how to solve this problem?
How does a node know that it has to resubmit
I think it has to.
A proposed fail, and it has to do a new deploy and propose again.
My question is this problem only in this block? Well, I mean, only in this, only for this deploy, or the whole block? You know what I mean? This deploy is invalid, right? But all the other transactions in this block for this validator maybe are okay. So.
Yeah.
I mean, right simple contract. Yeah.
I guess I'm just, I mean, I don't know how we can implement a sequential process such as this, and know that I have to resubmit or redeploy or do something to, oops, we all got number 5, so one of us gets number 5. When that happens, then we can all try to get number 6.
Yeah, it's more like an asynchronous like feedback where you could somehow figure out exactly when it can be determined that you can not upload the block that you tried to upload, that you could be notified.
Yeah, and it seems like the whole, wouldn't the whole block fail?
The whole block wouldn't fail because they wouldn't accept your request because one had already existed there. So if you uploaded the block as a proposal, then that would fail. But if you just upload your transaction and somebody else builds a block out of it, they'll just reject your transaction.
I mean, could it be as simple as like having a message sent back to the people whose requests are not processed, just saying like, hey, you need to like deploy again or something along those lines?
But on which channel you can use for this kind of communication?
Yeah, so maybe when you send your request, okay, right. You also send some channel along, right? And then it's like, oh, let me know if my request went through or if I have to do this again.
Yeah.
Wait, like a relaying channel?
Yeah, sure. Why not?
Well, then they'd have to submit a new transaction onto the chain, right?
Yeah. Yeah.
So, okay. Seems a little bit circular. Dude, so is there not some scheme for like just generating like a batch of channels that one validator can use or one like deployer can use or something? Or is this like way more complicated? I'm just not thinking about all of the pieces.
Oh, no.
So for me, the blockchain is a completely closed thing. The only thing you can do is a standard output, which is not really on the blockchain, right?
Yeah.
So you don't have a way to send something outside of the blockchain. This is why I wanted to have some kind of direct connection to the blockchain from the node. So you can say, I will keep eye on this channel and use HTTP, I will use like a Google push notifications when something changed on this channel. So
okay.
This is how I think.
You're saying, but that would be like communication externally, like outside of like off-chain, basically, right?
Yeah, but in a sense, standard output is like off-chain.
Yeah.
Standard output is waiting on some special channel to do something.
But it's like maybe I don't know, maybe you can make these notifications like really controlled off-chain communications, but standard out just seems like a really controlled environment for like off-chain communication. Yeah, interesting.
It would be nice that you don't have subscription. You only have this listening on the name. You can just check. Is there something on this name?
Yeah. So okay, maybe I have a misunderstanding about how people are generating these like unforgeable names for private channels to communicate on. So like how does that process work? Like I'm a validator, I want to generate an unforgeable name so I can get some private messages or something. Like what is the protocol for going about doing that?
So from the public key you can generate unforgeable name.
Okay, and I can do that like at will. I can just generate as many as I want. Yeah.
This is like a standard algorithm.
Yeah.
Okay. And then you can listen and check. You can check is there something on this thing.
Yeah. Okay. So I mean that's sort of what I'm saying, right? Like I can generate one of these unforgeable names, send it along with this request to like get my ticket number or something along those lines, and if my request isn't the one that's validated or finalized or processed or however you want to phrase that, then maybe I can get like some acknowledgement message back on this channel that I provide saying like, hey, your request wasn't processed.
Yeah. I was thinking that you don't have to.
I don't understand how it gets to that point. I mean, let's get it. I mean, there's activity on the node. Okay, then we do a propose. Okay, this deploy is maybe along with a bunch of other deploys of other stuff.
Yeah.
Okay, and the block and it just fails, and we don't know what failed. Really. Do we?
Well, so okay, maybe I have a more fundamental question about it then. So like, say 10 people are trying to get the ticket number all at the same time. How does the person who actually gets the ticket number know that they got the ticket number, and how do you actually know what number you get?
Yeah, the block has to reach finality. Until then,
So
the block. Yeah, right. Yeah, you're absolutely right.
Now you can check when this is the final.
Yeah, so really it's more like the responsibility, I think, of the submitter than anybody else, because everybody figures out at the same time.
Yeah. Okay, that makes
But I'm not sure that you can easily check when it's not finalized. Right. The one question is this block finalized? But maybe it's not too easy to check if a block is not finalized.
So you could have like a separate network that can send proofs to people that blocks are finalized.
No. I mean, you're waiting for your block to be finalized, right? But it's I'm not sure. Can you easily check? So
yeah, right.
Yeah, wait. So how do you check if a block is finalized? I mean, can you like look at all of the blocks? Is there like an ether scan type of thing where you can just like go and check the latest finalized block or something along those lines?
So I was asking this Arthur, and he was saying that they are now doing this work of, how can you be sure that this value that you are listening, that you are getting for this channel, that you can be sure that it's finalized, right?
Yeah.
Because you want the final value, not something in between.
Yeah, because this seems really complicated. Like Jim is saying, I mean, it's like you want to do something which seems really simple on the face, and it's like, okay, I just want a ticket number, and like only 10 people are sending in these requests for ticket numbers, and then like, oh boy, but we got to wait until this block of transactions is finalized before we even issue one ticket number, and so we're waiting at least 10 finalized blocks. Like, I don't know.
Yeah.
That seems.
But Isaac, you suggested. I think we don't need to generate these numbers, ticket numbers, in this time, in time of deploys, right?
Yeah.
We can collect our. So you can submit your unforgeable channel, right?
Yeah.
From your contract. And this ticketing contract can just collect in parallel all the applicants.
Yeah, applicants. Yeah.
And after the fact, after the closing, the ticket sale or whatever, you can just
do some sort of ordering, maybe based on like order that you received it or something. I mean, I don't know, whatever the condition is, but you just
ordering
on these ticket number applications.
Yeah.
We can always try it on the sandbox and see what happens.
That sounds cool.
Yeah.
That's a good point, though. Is like you really have to write the contract to reflect the blockchain infrastructure, rather than trying to have the blockchain meet the contract's requirements.
Yeah.
I mean, I guess Chris. I'm not sure who else. When I brought up this problem in the past, people have suggested that somehow the problem won't come out. I don't know how that could be possible, that the problem doesn't come up. You're talking about, until somebody actually looks at the ticket number, well, the ticket number goes on the log. Yeah, I don't know. In any case, I think that's a
But Jim,
significant problem.
What is the core of the problem? You really want to sequencing over the network, right? You want to know who sent the request before who, right? Order of deploys. But I'm not sure this is possible, right?
Yeah,
you cannot say kind of.
Yeah, we're trying to serialize. We're trying to serialize.
You can collect
globally. Okay, we're trying to do a global serialization.
Yeah.
And
but serialization of deploys. Maybe there is some kind of other way to do.
Yeah, if the order of the tickets doesn't matter, if it doesn't matter which ticket number you get, or it does, doesn't it?
Yeah, Jim, you want to have like a specific order, right? You want to have some kind
Or
of
like, would somebody prefer to be 4/5, or is it more just like a number for
first 100.
Oh, I mean, it should basically be first come, first serve, but as long as they're unique, we don't care.
Yeah.
I mean, it's like things that are close to the same time, the order doesn't matter.
Yeah, I
Just like
don't think you can achieve first come, first serve over, this asynchronous network. But you could achieve assigning people that simultaneously submit for tickets. You could get them all a ticket number.
Yeah, a unique ticket number.
Yeah, a unique ticket number. It's not necessarily first come, first serve.
So how does, like, presumably you can do this on Ethereum, right? How does it work on Ethereum?
I mean, I think Thomas Love is right that you would, just like an initial token sale or something, you have just a list of people that submit for the token sale, and then you have the event later on.
Yeah, you're not deciding those ticket numbers as requests come in, right? It's like they're open for whatever number of blocks or something along those lines, and then like whatever, you get a batch of requests, and then you just assign unique numbers to that to each one of those requests, right?
Yeah.
I mean, that makes sense. I feel like that has to be like one of the only ways to do it, but I don't know.
Yeah, and it's tricky if you want to choose only like first you're giving some free tickets, So only the first 100 will be given the tickets. So how can you choose what is the first?
Oh yeah, right. How do you come to consensus on who the first 100 applicants were?
Yeah,
well,
yeah.
That's the problem, right? I mean, like, because now you're just expanding 1 to 100, right? Because we're trying to decide who was the first one to submit the request, but
yeah.
Presumably different validators are getting requests from different people and different first requests from different people.
Yeah.
So can you? It would take a really long time to come to consensus.
Right.
Yeah, but if you have a limited number of messages.
Yeah. I think I think there needs to be a way to say, give me the finalized value of this. Read a finalized read as opposed to a regular read.
Yeah.
If you're trying to, for in the case where you are trying to really serialize something.
Yeah.
I could see that being a problem, though. I mean, essentially, it's going to, and in that case, each of our contracts would be reading the I don't know how that would work. Okay, we're all reading the last num, and we want a finalized value of the last num. Well, okay, the last num starting at 0, that's a finalized value. There's really no way to, I don't see any easy way to do this. To really serialize something on our chain seems to be almost impossible.
I mean, the only way is that you send some other acknowledgement channel and some other, this next deploy is sent to this channel, and then you have all this nesting, right? With nesting, you get sequencing.
Yeah, yeah, and that would work for the consensus level too.
Yeah, but then you need to wait for each deploy, for each user to give you the channel, and then this is also not easy.
Yeah, so you can serialize, it'll just be as slow as the block generation is.
Yeah, exactly. Yeah.
So I mean, in that kind of scenario, is it you're coming to consensus on each ticket number like sequentially almost? So like, okay, we need to come to consensus on who was the one that gets ticket number 1 first, right? And then once we come to consensus there and the block is finalized and everything, then we can move on to ticket number 2, right?
Yeah.
Yeah, I mean, I guess you could submit 2 sequential processes in the same block, right? As long as they're both valid.
Yeah, I think that's right.
So the best thing in this situation is to send your request to all validators for the ticket, right? You just send to all. You will be the first.
Yeah.
Everybody sends to every validator.
If you could coordinate locally with the people and decide an ordering and then submit that would be.
Yeah.
But, yeah.
So okay, do you have a choice as to which validators receive the messages that you're deploying to the blockchain, or does that like in some sense get gossiped around anyways, and eventually everybody is going to see it, right? Or maybe see it as I don't know, something that another validator has finalized, or I don't even know how to ask the question I'm trying to ask, honestly. Do you have control over which validator sees your deploys, or is it just like you're sending it out to the network and whoever happens to receive that deploy is going to see it?
Well, you have to have permission to access a validator.
You have to have permission to access a validator. Okay.
But on which permission do you mean? Now you can deploy to any validator, right? And this is the only way now. I mean, Kelly was mentioning some validator pool, but I'm not sure what this is. I was imagining that the pool would be some kind of proxy server in front, which will deliver.
I guess as long as you have can pay for the transaction, I guess that there's no reason you couldn't connect to a validator.
How does our chain guarantee today that a validator doesn't get DOSed?
Well, there's a cost to the deployment.
Right. Yeah, we're not paying right now, so
yeah.
There is no protection.
Well, yeah. So you could just DOS the testnet if you wanted to, I guess.
Yeah. Not even necessarily the network itself, but just the validators. Like if you tried to DOS their bandwidth.
Yeah. Yeah, it seems almost like you wouldn't want to be able to send messages to specific validators, because then you could target specific validators with like DOS attacks.
Yeah, it does seem more dangerous with proof of stake, or more like susceptible.
Yeah.
Why would anyone not be a validator in a proof of stake system if there's no like mining going on?
Yeah.
The validation's just being alive and responding to network calls.
My guess is like hardware costs, and I mean the fact that you do have to put stake on the line.
Yeah, this is a good point, because in a normal proof of stake network, you have a leader-based protocol, and so that's why you need validators, or a set of validators that everyone knows. So not just anyone can be a validator, because
Right.
you have to decide on the set so that you can always choose a leader. But is our chain is a block DAG. Is it leader based still? Are certain validators choosing the blocks, or?
I know that Greg is saying that it shouldn't be leaderless. It shouldn't. It should be leaderless.
It should be leaders.
Should be leaderless. I mean, that was my understanding of it, but I think you can tell from the questions that I'm asking that I don't have a really coherent understanding of like all of the blockchain architecture, you know?
Yeah. Yeah, that's an interesting one. I feel like you probably need a validator set in any proof of stake system, because otherwise how do you like decide finality? Like how do you decide when a block has reached the 2/3 majority?
So wait a second, aren't there like validator rotations or something in our chain? So I think maybe there's only a certain group that's validating at a particular time, and that changes over time. I remember that from somewhere. It's been a while though since I've thought about that.
Okay. Yeah, that's like Tendermint, which is kind of like leader based, just multiple leaders.
Yeah.
Yeah.
And how is it in Hashgraph? They have this guy. I remember he was not talking about this, like a fixed number of validators, but I'm not sure how this works.
They do kind of, I guess, they don't like explicitly really talk about proof of stake in the system. They just briefly say, you know, you can consider two separate validators as one with two coins. But, you know, they define the protocol where finality is 2/3 of all validators strongly see something. So they do have a conception at all time of all the validators in the network. So I think that is important in any proof of stake system, that you always know exactly who the validators are. Which I guess, you know, takes out the permissionless aspect. You kind of always need some like decided upon group.
But you have this way of bonding and unbonding, right?
Yeah.
And you can do it. You can do it this dynamically, right? So you can say we can have different number of validators in different time.
Yeah, I think that's right.
Yeah, I know the way a lot of chains do it is like with follow the Satoshi algorithm, which just everybody submits some amount of stake that they want to be in the network, and then you randomly choose from that stake pool, and they use like the randomness of each round to decide the next round. And so you always get like a validator set of some size, and it's always just randomly chosen next with the rotation. That's how it's normally done. But I've never seen it done without a validator set.
You know, the synchronization problems that you're talking about, to me, that's like the same problem that, you know, the classic cryptocurrency problem. Like you have a UTXO, some value, you want it to be valid based on the most recent stuff. And if you can make a token with Rolang, then you're already doing something that implies synchronicity of some sort.
Yeah, this makes sense. Joshi was saying that, you know, UTXOs are like a DAG and not just like a chain. So, yeah, that makes sense.
Yeah.
I think it would be cool if there was a idiomatic way to do this within Rolang. You know, the concurrency stuff is nice, and it's very similar to any other language where you can define threads and They get joined at some point. You don't care about the execution order, but in all of other languages, they all have some synchronicity method where you if you're creating mutex locks for variables, or like if you're using atomic types to guarantee that reads happen after writes for given junk, you have to have stuff like that for certain applications. And if Rolang right now just doesn't support like really easy to use fundamental operations like that, then you're going to have all kinds of problems with dApps that are trying to do simple things like Jim's little ticket counter is. So, but I was also wondering, can you not just listen? Like if I create a smart contract and I only have one receive on some channel name, I can't I can't receive messages on that. Like can another contract send on that channel name and I'll be able to see those, or are they all like independent?
But so what Jim was saying, it's not the problem with the rolling. It's a problem with multiple rolling with virtual machine when you want to make a consensus, right? Inside the rolling, you can easily sequence everything, right? But when you want to make consensus between different executions, then you have this problem.
It's global consensus, and
yeah.
And I mean, in thinking about this, we have the case of where we need an oracle, and in the case of an oracle, well, we have two cases. We have one in a case where they always return the same thing, so that all the nodes can call the oracle and get the same answer from the oracle, or the answer each will get is unique. Okay, so we could have a simple counter oracle that would return a sequential number, and each so when a block is deployed and you get a certain value back from an oracle, okay, you're the only witness to that oracle statement. Okay, so the other nodes don't have to validate the value you got from that oracle, because you're the well, they may have to, but well, it could be signed, for example, so that it could be validated without accessing the oracle again. That's what I'm saying. I mean, that kind of thing can be used to solve this kind of problem. And there's
this looks like that you have only one specific node that all the validators will ask for the ticket number, right?
Well, it would be a service, yeah.
But this could be like one of the validators can say, well, now I will serve all the numbers, right?
Yeah, I mean, there's other issues. I mean, certainly in terms of how you decentralize your oracles or whatever. But
yeah, this is interesting when you say it like this, right? You say, oh, the oracle is something that all the validators will ask, right?
Or
This is
not,
like a,
or not. No, in other words, I access. Okay, we access an oracle. Let's say an HTTP address using your HTTP connection oracle, whatever. Okay.
yeah,
Okay, we get back a result. Okay, now if that result is signed, it doesn't have to be repeated by the validators.
yeah. Each of the other validators will get, for example, this can be a timestamp, right?
Right.
Or a sequence of numbers. And each of the validator will have a proof that he's given this number from the oracle, right? With the signature or whatever.
Right. So, yeah. So when you're deploying it, you access it, but when you're validating it, you're just checking the signature.
Yeah, yeah. And this is very similar to what Mike was saying. You know, when you do some multi-threading programming, you have some locks or atomic operations that you want to
Right.
sequence.
Right.
So in that case, it's very similar. Yeah, yeah. Yeah, maybe validators need to play some kind of meta games. What Joshua was proposing, you know, to get this ticket number from the. This meta game is really an oracle, right? So.
All right. Well, let's see. 11:17. Do we want to stop the recording now and go to computational calculus?
Yeah.